So in this session, this is model 4. In this session, let us see the physical layer procedures and scheduling. So here we will see the topic, that is HARQ feedback and the CQI feedback. In this session, let us discuss only about the hybrid automatic repeat request feedback protocol. In LTE, this HARQ protocol is used for the transmission reliability. So if you use this protocol, the transmission reliability will be good over the wireless channel. And this this HARQ we will call as soft combining process. HARQ, or otherwise we will call it as a soft combining process. So what do you mean by the soft combining process? The soft combining process is nothing but the function ARQ, that is automatic repeat request process, along with that ARQ process, forward error correction is also be done combinedly. So here this HARQ is implemented mainly to correct the error packets in the physical layer. So let's see here. And to further process, two methods of HARQ protocol are used in the LTE. That is nothing but asynchronous adaptive HARQ protocol and synchronous adaptive HARQ protocol. So first, if we talk about the asynchronous adaptive HARQ protocol, so it is used by the downlink transmission. So here in this LTE we are discussing about downlink transmission as well as the uplink transmission. So in the asynchronous adaptive, we are this will be used for the downlink transmission. So here retransmission is the major thing here. Due to the scheduling process, retransmission will take place in time. So whenever this retransmission is taking without any scheduling, there is one flexibility, so that the flexibility will be increases when in the asynchronous adaptive protocol. So so if you think about this asynchronous adaptive protocol, it is used for downlink transmission. So there is no scheduling process, the flexibility will be increased. So let's coming into the synchronous adaptive HARQ protocol. So by the name itself, we are using this in uplink transmission. Here at fixed interval, the retransmission is taken place. Okay, so because of this, what is the benefit? Or we can reduce the overhead. Okay, we can reduce the overhead, and there is no need of no need to include any process ID, HARQ process ID in the outgoing data. Okay, so this will work in cyclic basis. If there is no resources allocated during a specific subframe also, this process will be happened in a cyclic form. So that's all about the synchronous adaptive protocol. And this HARQ feedback is different for duplex. Two duplex techniques we know, that frequency division duplex and the time division duplex. But this HARQ feedback is not same way, it is working in the same duplex method. For FDD, the HARQ feedback is different. For TDD, the HARQ feedback is different. First we will see the HARQ feedback for FDD mode. The procedure, see here, the user equipment will transmit the HARQ acknowledgement in the subframe. Okay, for the downlink shared channel transmission, but there is a subframe n-4 delay is there. So why this delay is happening, in the sense, at the receiver there is a processing delay of 3 milliseconds. There is a processing delay of 3 milliseconds. So due to this delay, the 4 subframe delay in the transmission of acknowledged message is happening. So here we can see for the n subframe, the user equipment is transmitting the HARQ acknowledgement, but there is a delay of 4 subframe delay. Why this 4 frame delay is happening? Because at the receiver there is a processing delay of about 3 milliseconds. So this HARQ acknowledgement and scheduling request are transmitted in the same subframe. So in continuation of this types of HARQ protocol, that is asynchronous adaptive HARQ and synchronous adaptive HARQ, we have seen the HARQ feedback mode, that is FDD and TDD. Now we will come for the TDD. That is nothing but the time association is very important. That data transmission and the acknowledgement transmission is also there. So how we can maintain this time time between the data transmission and the acknowledgement transmission? So for that we are it can be maintained, okay, due to the variable numbers of downlink and uplink subframes. Okay, instead of being present in a frame, we can make it into number of downlink and uplink subframes. So that is here, it is clearly mentioned. So this uplink and downlink delay between data and acknowledgements is depend on the time division duplex configuration. In what way we are going to choose, in what configuration we are going to use the TDD configuration. So here this configuration can be chosen such a way that two acknowledgement feedback modes, we will considering the two acknowledgement feedback modes that is supported by higher layer configuration. So we are categorizing into two. It is nothing but acknowledgement and negative acknowledgement bundling one, and another one is acknowledgement or negative acknowledgement multiplexing. So if we use this bundling, okay, this bundling is using the uplink control channel. We are aware about that. This uplink control channel is having the format that is 1A 1B 2A 2B. So here for the bundling we are using a 1A or 1B, and here 1 or 2 bits of information will be there in this format. Okay, and if you come for the multiplexing we will use the format 1B, and this format 1B consists of 1 and 4 bits of information. 1 and 4 bits of information. Then followed by this, let us discuss about the HARQ indicator for uplink transmission. So here this we want to transmit or send some indicator. This, for example, how many bit of HARQ indicator is need to send a scheduled user equipment. We already know that the user equipment is this transmit in a fixed schedule interval. So here we need only a single bit HARQ indicator to be needs to send each scheduled user equipment. For the FDD mode, now again we are coming to the modes, FDD mode and the TDD mode. Here if you using the frequency division duplex mode, that user equipment in subframe is associated with the uplink shared channel transmission with the delay of 4 subframe, that is n-4. But in the case of TDD mode, it is different from the feedback for downlink transmission. That means there is no problem to transmit multiple acknowledgements on the PHICH. So this is all about the HRQ indicator for uplink transmission. So in this session we discussed the HARQ protocol, and it is about the soft combining processes, followed by the two types of HARQ protocol, that is asynchronous adaptive HARQ protocol, synchronous adaptive HARQ protocol, and followed by the two types we have discussed the two HARQ feedback modes, that is nothing but frequency division duplex and the time division duplex. And here just the last topic we discussed is HARQ indicator for uplink transmission. Hope you can differentiate all these functions, and hope you might have understand. Thank you.